Good evening, guys. Let us do a beautiful problem. Here, a right angle triangle is given A, B, C. Right angle at angle C. Right. Now, a perpendicular is drawn on AB, perpendicular bisector. Right. AD is equal to DB. This means AD is equal to DB. So that's why DE is a perpendicular bisector. It is dividing AB into two parts, and at the same time, it is perpendicular to AB. Right. Now, the length of AB is 20 and the length of AC is 12. What we need is area of ADEC. That's why this is a beautiful problem. This is a quadrilateral, right? Area of quadrilateral we want. But looking at this problem, we are able to see two right angle triangles, right? ABC is one right angle triangle. BED, this is another right angle triangle, right? At the same time, we can also see this 20 and 12, right? That means a Pythagoras tuples, right? 3 4 5 kind of thing. 12 16 20. That's a Pythagoras tuple, right? We can see that also. So let's use this to try and solve this, right? What is the area of ADEC? Area of ADEC is total area of ABC minus area of BED, right? Because these two are right angle triangles, it can become little easier to find the areas of these triangles. Let's see how. Okay. Now, if you notice, BED and ABC or BCA, BED, this triangle, and BCA, this triangle, these two triangles are similar. Why? Because one angle is B. B is common between in both the triangles BCA and BED, and another angle is right angle. Right? When two triangles, one of the angles is right angle and another angle is common, what does that mean? Automatically, the third angle is also equal. That means both triangles are similar, right? So please notice the figure. ABC is like this, C is the right angle, but BDE. So we have to flip this on EB. On EB axis, if we flip this triangle and so that this D goes this side, then we get this figure. So these two are similar, not just rotation, we have to flip also, right? If you flip along EB so that D goes this side and maintaining the same length, right? DEB is similar to CAB, right? One of the angles is right angles. In this case, this is right angle. In this case, this is right angle. This angle B is common to both the cases, right? Now, area of BDE, this triangle, by area of this triangle, right? BDE, or in fact, I will write BED. I'll write it as BED. BED by BCA. BED by, sorry, BD is better format because in that way these two are similar. For example, BD is the corresponding side of BC, right? Similarly, DE is corresponding side of AC or CA, right? That's why this notation is better. Now, area of two similar triangles is equal to the area of two similar triangles. The ratio or the comparison of these two areas is equal to a ratio of corresponding squares. But how do you know who said this? Because the legendary mathematician Euclid said this. Right. We have already proved this also. We have already referred to this and we did the proof of this also. Area of two similar triangles is always equal to the ratio of area of two similar triangles is equal to ratio of squares of corresponding sides. This is Euclid's sixth book, 19th proposition, which we have already proved in the earlier video, in one of our earlier videos, right? Please go through that once and let's directly use that proportion now. So area of BDE to BCA, yes, is equal to the corresponding. 10 square by 6 square, because these two parts are equal, right? BD and AD are equal, that is what that is given. So BD is equal to 20 by 10, 20 by 2, that is 10, right? So 10 square by 16 square, right? At the same time, area of BCA. BCA, we can calculate area in another way also, because this is base and this is height, or this is height, this is base, this is height. We can do whichever, we can take whichever base or whichever height. But because this is right angle, half into 12 into 16 is also the area of BCA, which is 96. Right. Now we know the ratio of areas of BDE and BCA. So area of BDE will become 10 square by 16 square into this 96, which comes out to 37.5. Right. So we calculated this area. Now what is the area of ADEC? The total area, which is 96, minus this 37.5, which is 58.5. Please notice BED or BDE. This triangle is similar to this triangle, but it is not 3, 4, 5. It is 7.5, 10, and 12.5. Right. It's not 6, 8, 10. Please notice. Right. The 16 length corresponds to this 10 length. It is not 20 is corresponding to 10. Please note that the 16 is corresponding to 10. Right. This DB is not the hypotenuse. EB is the hypotenuse. Right. So DB is 10. So correspondingly, DE is 7.5. That means this is 7.5. This is 10. Sorry. This is 7.5. This is 10. And this one is 12.5. Right. So as a broad rule, in any within a right angle triangle, right? Within a right angle triangle, if there is another right angle triangle, then both we can use this property to make both of them similar, because one of the angles is equal. In this case, one of the angles is equal, and another angle is right angle. So if these two are satisfied, two angles are equal, that means the third angle is automatically equal, right? And we use the Euclid's proposition to find out the ratio of areas, which is equal to ratio of their squares of ratio of squares of corresponding sides. Right, guys? Hope you like this. Thank you.